Okay, so that's right. So this was the integral that we ended up with in exercise 5.2.12 that this NI9 refers to. And so compute is what this exercise is about. So we have to take our shape. Now our wall was like this. So the height was 9 and the width was 20. That's the x-axis, the y-axis. So what we're going to have is an integral. Conveniently, it's a rectangle, right? So x goes from 0 to 20, and y goes from 0 to 9, and then all of this nonsense goes into there. Okay. Yikes. Okay. So yeah, So let's do let's go ahead and, all right, here we go. So I'm going to need some space here. Let me just skip down where I have more room down here. So integral from 0 to 20 dx. And let's see, integral from 0 to 9. Now I want to multiply out all of this stuff. So conveniently, there's been constants that'll just factor right out. The 20 factors right out. The 12 factors right out. And then I'm left with 3y. Let's see, I've got to put in here I have 20 over 12, which is 10 over 6, which is 5 over 3. So, yeah. Okay, so what's left is 3y and then minus y sine of pi x plus y over 3. And I guess I didn't need that much space after all, dy dx. Okay, everybody good? I forgot who asked me this question. Was it you? Okay, yeah, okay, great. Okay, so we have then, now we're going to be taking antiderivatives. Let's go ahead and do that now. The y antiderivative of all of this is 3/2 y squared. And let's see here. Now we're going to have to do some work to figure out what the antiderivative of this is. And this is just an integration by parts problem. Let me do that on the side over here. Antiderivative of y sine pi x plus y over 3. Well, I'm going to let u be y, and then v prime is the sine business. Then u prime is 1, and v, I'm going to need to take the antiderivative of the sine business. And when you take the antiderivative of sine, you're going to get negative cosine. But then you also have to you have to do a substitution. So you're going to kick out an extra factor of 3 over pi, I claim. So you're going to get 3 over pi times negative cosine of that stuff. Is that okay? Is that right? Let's see, antiderivative of sine is negative cosine. Yeah, I believe that's right. Okay, so the antiderivative then, the antiderivative of u v prime dy is uv so we have minus 3y over pi cosine pi x plus y over 3 minus, now there's a minus there, but then there's a minus from the integration by parts formula. But then there's another minus in here also. So altogether that's 3 minuses. So that means that we have a minus here. The antiderivative of u prime times v. So that's 3 over pi. That minus is from that minus. Yeah. And then cosine pi x plus y over 3. So that was the antiderivative of this business. Let's not forget we have a dx over here. This is going to be evaluated over a certain range of values of y. I'm being super sloppy with this. My apologies. Okay, is everybody cool so far? Okay. Now, of course, I've got this antiderivative. I should have done that over here. I should have worked out this antiderivative over here. Anyway, so we have 5/3 integral from 0 to 20. 3/2 y squared. 3y over pi cosine pi x plus y over 3. And then let's see, well, the antiderivative of cosine is sine, but again, when you take an antiderivative substitution rule, there's an extra 3 over pi, and so we're going to have minus 9 over pi squared sine of pi x plus y over 3. And again, we plug in certain values for y, well, specifically 0 and 9 for y. And you plug in these, so 0 and 9 get plugged in for y and all of this stuff, right? Inconvenient, right? And that gives you a great big function of x, and you take an x antiderivative. So it's just going to be some tedium. Yeah, okay.
So it's just a note, like,
yeah.
In the inner parentheses, we have x plus y. If you treat, since you're doing dx, if you treat y as a constant.
We're treating x like a constant because, yeah.
So do you pull the x out too? Like,
the x stays there. X is a number.
Okay.
It treat it like a k. It just stays there.
Just stays there.
Yeah, and then of course once you've plugged in your y's, you reinterpret that x as being then the variable for the next antiderivative, for the x antiderivative. Yeah, right. So when you're doing the y antiderivative, it's just a constant. You treat it like a constant. And when it's when you get out to the x antiderivative, then it's the variable. Yeah. Okay, so it's just tedium at this point, and it was in fact a lot of tedium up to this point, but it's going to be a little more tedious when you plug in numbers. It's sort of twice as many terms anyway.